Okay guys, so welcome sa ating YouTube channel. So ito yung ating lesson 9 o yung video number 9 sa complex analysis. So ito yung Cara, Theodory, Lemma. So another way para makuha natin yung derivative ng isang complex variable or isang complex function is through using Cara, Theodory, Lemma. Okay, so sa next video, si Cauchy-Riemann equation naman. So marami talagang way para makuha yung derivative. So before that, syempre mag-start muna tayo dito. So the common differentiation formulas. Okay, so let f and g be a complex variable or a complex valued function such that f and g are complex differentiable and z is element of complex number, meaning si c is a complex number. Okay, so number 1, the derivative of f of z with respect to z is equal to f prime of z. Number 2, the derivative of constant where c is a complex number is equal to 0. Okay, the next is the derivative of c times f of z is ilalabas na natin yung z, so hindi ko na nilagay dyan kasi common sa atin yun. Okay, then number 4, the sum of the derivative or the sum and difference of the derivative is equal to the sum or difference of their derivatives. Okay, then next ito yung ating product rule. So alam nyo na yan, yung parang udv plus bdu, ayan yun. So f of z times g prime of z plus g of c times f prime of z. Next is yung quotient rule. So that is the derivative of f of z over g of c with respect to z is yung ating g of c, f prime of z minus f of z times g prime of c all over gc or g of c raised to 2. Okay, then last is number 7 is yung ating tawag dito, power rule. Okay, so whenever meron kang f of z naka-raise sa n, so that is only equivalent sa n, bababa yung n, then f prime of z raised to n minus 1 times the derivative of f of z. So usually dyan sa power rule nag-exist si chain rule. Tama? Okay, so let's have example. So example muna tayo niyan before tayo talaga magpunta sa topic, which is the Cara, Theodory, Lemma, bago ko siya i-define. Kasi nga, siyempre, kailangan ko lang kayo ma-recall din na ganito lang din mag-derivative dito. Okay, so for number 1, let's say number 1, what is the derivative with respect to z ng 2 plus i? Okay, so note that si 2 plus i is a complex number. Okay, so sabi ko nga dito, the derivative of any constant is 0. So what is c? C is an element of complex number, meaning si 2 plus i is a complex number, therefore the derivative of this is equal to 0. Okay, so ganun siya kasimple. So kino-consider si 2 plus i dyan as constant, tandaan yan. Okay, so number 2, let us have number 2. So what is the derivative with respect sa z ng z raised to 8 plus 2z I minus 2z. Okay, so ulit mga iniisip ko rin din na example yan. So ano nang gagawin natin? Syempre hatiin natin, gamitin natin yung mga rule kasi sayang naman kung in-explain ko recta derivative. So dito gagawin natin, this is equal sa derivative with respect sa c ng z raised to 8 plus the derivative with respect sa z ng 2z I minus the derivative with respect sa z ng 2z. Okay, next is applying power rule dito. So by power rule, this is 8z raised sa 7. Okay, then ilabas ko lang muna dito yung ating constant, which is 2i, then the derivative with respect sa z ng z minus, lalabas ko din si 2, the derivative with respect sa z ng c. Okay, so note that the derivative of z with respect sa z is 1, the derivative of z with respect sa z is also 1. So therefore, this is equivalent sa 8z raised sa 7 plus 2i times 1 is 2i minus 2 times 1 is just 2. So therefore, ito yung kanyang derivative. Okay, so tandaan ha. So akin ina-apply ko yung formula or yung ating differentiation formulas or yung property para magamit naman kasi yung Cara naman nire-recta na lang. Okay, so number 3. Let us have number 3. Suppose we need to obtain the derivative with respect sa z ng z raised to 8 multiplied by let's say z raised to 2 minus 1. So ito yung factor. Okay, so obviously ito ay product rule. So by product rule, ano sabi ni product rule? That is that is f of z times g prime of z. So meaning this is equal sa z raised to 8 times the derivative with respect sa z ng z squared minus 1 plus z squared minus 1, then the derivative with respect sa z of z raised to 8. Tama? Then we get the derivative. This is equal to z raised to 8 multiplied by 2z. Okay? Then plus this is z squared minus 1. Then the derivative of z raised to 8 is just 8z raised sa 7. Okay, so lagyan ko lang ito ng parang ating bracket or ng parenthesis. Then simplify further. This is equivalent sa 2z raised to 9 plus, multiply ko lang, so this is 8z raised to 9 minus 8z raised to 7. So therefore, ang kanyang simplified form is 10z raised to 9, since parehas pa sila, or like terms, minus 8z raised to 7. So ito yung kanyang derivative. Okay, so nakapaglagay na ako ng ating quotient rule, ng product rule. So syempre kailangan natin ng quotient rule. So number 4, dalian ko na lang. So this is let us obtain the derivative with respect to z ng 1 over z. Okay, so alam ko meron kayong formula dyan pag 1 over x. Alam ko meron yan. So ayoko muna gamitin natin si quotient rule para mas makita natin or ma-appreciate. This is equal sa z times derivative with respect sa z of 1 minus 1 times derivative with respect sa z of z all over ito ay z squared. Tama ba? Yan ay BDU minus UDB over B squared, or simply dito siya ay g of z times f prime of z minus f of z times g prime of z over g of z raised to 2. Okay, so again, obviously this is equivalent sa 0. Ito ay 0 minus derivative of z with respect sa z is 1. So this is 1 all over z squared. Okay, so therefore ang kanyang derivative is negative 1 over z squared. Okay, or box ko na lang din. Okay, so tandaan yung mga derivative na yan. So kung paano natin ginagawa dati sa real number or sa calculus 1 nyo, kung paano siya ginagawa, ganun din dito. So pinagkaiba nga lang, lagi siyang with respect sa z, kasi nga dito usually si z yung dinidenote natin as complex number. Okay, so lagi din tandaan to, si 2 plus I, si 2i, hindi siya variable dito, siya ay imaginary unit which is constant in terms of complex number. Okay, so magpuproceed na tayo sa definition talaga ni Cara, Theodory, Lemma. Okay, so ito si Cara, Theodory, Lemma. So si Cara, Theodory's Lemma. So hindi ko to na-discuss sa advanced calculus since inabot ng pandemic. So dito ko siya madi-discuss talaga totally. Okay, so f of z is a complex differentiable at z is equal to z naught if and only if, note if and only if yan. Okay, so ulit, complex differentiable siya if it satisfies the following. So there exists p function. Okay, si p function is what we call the increment function. Okay, so ang goal natin dito maghanap ng increment function. So ulit, there exists an increment function which is a p function, d mapping to complex number. So yun yung domain, then that is equal to 2. So ang gagawin pagdating ng number 2, evaluate po si f of z minus f of z naught. So ang goal natin lagi, f of z minus f of z naught. After nun, kailangan makapagpalabas ka ng z minus z naught. Yun yung importante. Yun, kung sino yung nakamultiply kay z minus z naught, yun yung ating p function. Tandaan, kung sino yung katabi ng z minus z naught. So ang goal natin lagi dito, evaluate mo sa f of z minus f of z naught. Okay, then after mong certain parang operation or something, nagsisimplify ka, anong nangyari, dumating sa point, lumabas si z minus z naught. Kung sino yung nakamultiply nun, automatic siya yung p function of z. Tandaan. Then lastly, pag nakita mo yung p function of z, evaluate mo siya si p function of f with respect sa z naught or of z naught. So meaning substitute ko si z naught. Nung sinubstitute ko si z naught, siya si f prime of z naught as z approaches z naught. So meaning siya yung derivative. Okay? So let's have example. So una ipoprove ko to. Number 2, a-apply ko si Cara, Theodory, Lemma. So although a-apply ko rin si Cara, Theodory, Lemma dito. So dito mo papansin no, ang goal ko lagi makahanap ako ng z minus z naught. Tandaan yan. Okay, so for number 1, use CTL or the Cara, Theodory, Lemma to prove that the derivative of z, the derivative with respect sa z ng f of z plus g of z is equal to the derivative with respect sa z ng f of z plus the derivative of, with respect sa z ng g of z. Okay, so since Cara, Theodory yung lemma ang gagamitin natin dito, so assume, so to improve. Okay, so let natin na si p function of f and p function of g be the increment function. Be the increment function, be the increment functions of f, and g respectively. Okay, so ang sabi kasi doon sa assumption, di ba ang sabi doon sa unang definition, ang sabi let f and g be complex differentiable. So meaning since complex differentiable sila, nag-i-exist si p function ni f, nag-i-exist din yung p function ng g. Okay, so inassume ko yan kasi andyan talaga yan, kailangan yan. Okay, so i-consider natin ito. So, i-evaluate natin yung f of z minus f of z naught. Pero hindi basta yun. Ang i-evaluate natin si f of z plus g of z minus yung part na yun. So, consider itong part na to. So, consider. Okay, so consider natin si f of z plus g of z. So, siya mismo kasi siya i-evaluate natin eh. Okay, then this is minus dun sa f of z naught plus g of z naught. Okay, so yan yung goal natin. Next is evaluate natin siya konti. So ang gagawin ko, this is equivalent sa f of z minus f of z naught. So pag sinimplify natin upon simplification, so this is then plus g of z minus g of z naught. Okay, so next is since nag-i-exist yung p of f, nag-i-exist yung g of f, so by definition, di ba, tingnan nyo, f of z minus f of z naught, that is p of f, tama, p of f of z times z minus z naught. So meaning, itong part na to, equivalent siya doon. Gagawin ko lang tong g, i f. Okay, dito sa part na yun, gagawin ko lang tong g. Okay, so ulit ha, since nag-i-exist yung kanyang p function, pwede kong i-apply ito. Yung f of z minus f of z naught, nakikita mo yan, magiging ganun. Similar dito, papalitan ko lang yung p of f dun sa g. Okay, so this is equivalent sa p of f of z multiplied by z minus z naught. Okay, plus p of f of g of z multiplied by z minus z naught. Okay, next. Ang goal natin, kailangan malabas natin z minus z naught. Kaso dalawa yan eh. Okay, so ang number one goal natin, dapat nag-iisa lang siya dyan sa buo. So meaning, ipapactor out natin yan. So this is equivalent sa p of f of z plus p of g of z. Okay, ito ay nakamultiply kanino? Kay z minus z naught. So observe na nagawa na natin yung form na yun in terms of f plus z plus g of z. So anong nangyari? Meron tayong p sub f of z minus z naught. So nakikita ko z minus z naught. So therefore ito yung increment function natin. So therefore ito yung ating if o yung increment function. Okay, since yan yung increment function, ang gagawin ko, i-evaluate ko siya at z naught. Okay? Or, basta i-evaluate ko siya at z naught. Or kahit z na lang kasi wala naman akong z naught na i-specify dito. Okay? So, evaluate ko lang siya at z. So, this is equivalent. So, if is equal to p sub f of z plus p of f P of G, increment of G of Z. Okay? And that is equivalent sa, so that is equivalent, itong part na to is equivalent sa F prime of Z naught. Pero dapat F prime of Z lang. Plus, itong part na to, ito yung G prime of Z. Okay, sir, ba't walang Z naught? Kasi wala akong dinetermine. So, hindi ko sinabi na show that this is differentiable at Z is equal to Z naught. So, wala akong in-evaluate. So, ganyan lang yan. So, as if lang na Z. So, meaning, P of F of Z, P sub F of Z is F prime of Z na F prime of Z lang. Ganun na kasimple. Okay, next is, etong part na yan, sabi ng ating kanang definition, si the derivative with respect sa Z ng F of Z is equal to F prime of Z. Which is equivalent sa derivative with respect sa Z nung F of Z plus the derivative with respect sa Z nung G of Z. So therefore, nakuha ko siya using Cara, Theodory, Lemma. So this is done. This is by CTL or the Cara, Theodory, Lemma. Okay, so ganyan ko siya ipinurove using Cara, Theodory, Lemma. Again, tandaan ang main goal. Ang main goal mo, mahanap mo si Z minus Z naught, malabas mo siya. So pag na-factor out mo yun, yung katabi niyang part, yung naka-multiply sa kanya, yun yung increment function. So ngayon, ito yung gagawin natin dito kay number 2. Okay, so use CTL to prove that F of Z is equal to 1 over Z is analytic at Z is equal to 2 plus I. So, ang technique dito, yung Z naught kasi dati is dito is 2 plus I. Okay, so nakakalito kasi kung maghahanap ka ng Z minus 2 plus I. Kasi yun ang goal eh. Kailangan makakita ka ng Z minus 2 plus I. Okay, so in this case, ang gagawin ko tong Z naught muna. So, ilalet ko muna sa Z naught. So, afterwards, ipapalit ko na siya sa dulo. Okay, so walang proof na mangyari dito. Proving to. So, this is the proof. Okay, so proof. So, let us consider si F of Z minus F of Z naught. Okay, so dyan lagi. So, ang goal mo dito, kailangan may mag-exist na P function. Okay, so hindi pa natin alam kung may P function. Okay, so this is equivalent using our function. This is equivalent sa 1 over Z minus 1 over Z naught. Okay, so upon cross multiplication, this is equivalent sa Z naught minus Z, so cross multiply, over Z times Z naught. Okay, pero ang goal natin dapat makahanap tayo ng Z minus Z naught. So, meaning sa taas maglalabas ako ng negative 1. So, this is negative 1 over Z times Z naught. Then, ilalabas ko lang dito si Z minus Z naught. So, ano nangyari? Nag-factor out ako ng negative 1, hiniwalay ko na yung Z minus Z naught. So, kung napansin mo, ito na yung ating increment function. Tama? So, the increment function, so yung IF natin, so IF is equal to negative 1 over Z times Z naught. Okay, so next is i-evaluate natin. So ito yung ating P function of F. So yung P function of F, evaluate natin at 2 plus I. Okay, or meaning Z naught muna. Gawin mo natin Z naught. Okay, so Z naught, this is equivalent sa negative 1 over Z naught multiplied by Z naught, which is equal sa negative 1 over Z naught squared. Okay, so at Z naught is equal to 2 plus I. So P function of Z naught is equivalent sa negative 1 over, this is 2 plus I raised sa 2. Okay, so in that case, simplify pa natin syempre. Syempre, ayaw nga natin na may complex number sa ilalim eh. Okay, so this is equivalent sa negative 1 over, this is 4. Tama, this is 4i squared, so d3. So this is 3 plus 4i. Tama ba? So that is 2 squared plus I squared is 4 minus 1. So that's 3. So 2i times 2 is 4i. Tama yan. So, next is, i-conjugate lang natin. So, conjugate. So, this is 3 minus 4i over 3 minus 4i. Okay, so this is equivalent sa negative of 3 minus 4i. Okay, all over 9 squared plus 16 squared, which is 25. Okay, so hindi na ako nagkamali sa pag-multiply niyan. So sure na akong 25. Then apply na natin negative. So this is negative 3 over 25 plus 4i over 25. So ano yung kanyang derivative? So this is done using CTL. So ano bang ginugol? To prove that f of z is analytic. So meaning, since complex number lumabas, okay, so this shows that f of z is equal to 1, f of z which is equal to 1 over z is analytic at z is equal to 2 plus I. So kasi nga labas to, element to ng complex number eh. Since element siya ng complex number, alam mo nag-exist yung kanyang derivative at that specific z naught doon sa kanyang point. Okay, so ganyan ganyan ginagamit si CTL. So tandaan na, ang goal mo palabasin yung z minus z naught. So sa kahit anong paraan papalabasin mo siya dapat. Okay, so proceed sa next example. Okay, so for number 3, find the third derivative of f of z is equal to 2z to the fourth minus 3zi plus 4z cubed. Okay, so gamitin natin si CTL. Try natin kung kaya. So ano ibig sabihin? Tatlong beses ko gagamitin si CTL. Tatlong beses ko gagawin yung f of z minus f of z naught. Okay, so first CTL natin. So walang proof na magaganap. So using CTL. So first CTL or using CTL or using Cara, Theodory, Lemma. Okay, so una, let's evaluate f of z minus f of z naught. Okay, so that is equivalent sa, this is equivalent sa 2z squared, 2z to the fourth minus 3zi plus 4z cubed. Okay, minus, that is 2 z naught to the fourth minus 3 z naught raised to I times I plus 4 z naught raised sa 3. Okay, then syempre ganun ulit pagpa-factor natin lahat yan. Okay, so kung napapansin ko medyo parang mapapahirapan tayo pero try pa rin natin. Okay, so this is equivalent. So pagsasamahin ko lang yung merong possible. So 2z raised to the fourth minus 2z naught raised to the 4 minus 3zi minus 3z naught I plus 4z cube minus that is minus 4 okay, sorry, minus to 3z naught plus, ito ay plus, sorry. Okay, plus, then ito ay minus 4z naught raised sa 3. Okay, next, ipapactor out natin dyan yung mga z naught sa lahat ng yan. Okay, so, ang obvious, I guess, na ito, sum and difference ng 2 square, naka-raise sa 4 lang. Ito naman, obvious kita na natin. Dito naman, iba pa yung factor. Tama, so, gawin ko lang muna. So, ang gagawin ko, this is equivalent sa, lalabas ko yung 2, then ito yung unang factor. Z squared minus Z naught squared multiplied by Z squared plus Z naught squared. Okay, then factor out ko dito yung negative 3i. So, this is negative 3i multiplied by Z minus Z naught. Okay, then factor out ko dito si 4. So, this is 4 multiplied by Z minus z naught, nilabas ko na. Then some difference of 2 cubes. So pag difference of 2 cubes, ito ang factor na ito is z squared. So this is plus z naught plus z naught squared. Okay, so verify nyo lang din yung factor nung z cube minus z naught. Okay, next is common factor na lahat. Ito may z minus z naught to, no? So may matitirang z naught plus z naught dyan. Z plus z naught. Okay, lalabas ko na rin yan. So overall, ang ilalabas kong factor is equivalent sa 2 times z plus z naught. Yung matitira doon. Then ito yung z squared plus z naught squared. Then minus 3i plus 4 multiplied by z squared plus z naught plus z naught squared. Okay, then itong lahat ng to naka-multiply sa isa dun sa ating z minus z naught. Okay, so siguro first after nun i-derivative ko na ng basic kasi alam niyo naman na gagawin afterwards ha. Ulit ang gagawin ko sa first derivative is CTL, din sa second derivative and third derivative is yung normal derivative differentiation na lang. Okay, so obviously ito yung ating increment function. Okay, so yung IF natin o yung P of F natin as z naught. Okay, so ito is equal to, so apply ko yung z naught, so this is 2 times z naught plus z naught. Okay, plus z squared z naught plus z naught squared. Okay, so minus 3i plus 4 times z naught squared plus z naught times z naught plus z naught squared. Okay, so nakaka-z naught. So, mahilig tayo z. Next is 2z naught. Okay, so this is 2z naught. Tapos dito, so, ulit 2z naught times 2, 4. Tapos z naught squared times z naught is z naught cube. Tama? So, that is 2 times 2 times 2, 8. Okay, so this is equivalent sa 8 z naught cube. Kasi tatlo yan. Minus 3i plus z naught squared plus z naught cube, z naught squared plus z naught squared plus z naught squared is 3. So 3 times 4 is 12. Okay, so this is 12 z naught squared. Okay, so kung napansin mo, ang first derivative kasi nito dapat is 8, tama no, 8z cube, tama, minus 3i plus 12z squared. So tama yun, nakuha natin first derivative. Okay, so meaning nakuha ko yung first derivative niya doon. So pag kinuha ko yung third derivative niyan, o second derivative, so ano second derivative nun? So f prime of z naught. So kunyari f double prime of z na tayo. Kunyari assuming z yan, so this is 24 z naught, gawin ko ng z naught 24 z naught squared, then wala na tong 3i kasi constant, plus this is 24 na lang. Next, pag kinuha ko yung f third prime, yung third derivative ng z naught, that is equivalent sa 48 z naught na lang. Okay, so ito yung kanyang third derivative. So kung gagamit kang CTL, ito yung lalabas. Another CTL, ito yung lalabas. So anong nangyari nga lang, masyado kasi mahaba nung kinonbine ko. Okay, so kung nalilito ako, anong ginawa ko dito, pinactor out ko lang yung z naught, yung z minus z naught, ayun siya. Okay, so baka hanapin mo kung nasaan siya. Okay, so make sure na dapat alam mong gamitin yung ating Cara Theodory lemma. Okay, so let's have example number 4. So use CTL to show that f of z is equal to square root of z is complex differentiable at any z naught. So wala tayong specific na z naught na nilagay. Okay, so this is the proof. Okay, so consider natin si f of z minus f of z naught. Okay, so this is equivalent sa square root of z, tama, minus square root of z naught. Okay, so ito yung problema. Naalala nyo dati yung sa may algebra, kunyari 1 over square root, anong ginagawa mo? Rationalize. So, naalala mo yun. So ngayon, ang gagawin natin, derationalize. Anong ibig sabihin derationalize? Ibabalik natin yung square root sa ilalim. Yun yung term, derationalize. Okay, so this is equivalent sa square root of z minus square root of z naught. I-multiply natin siya sa square root of z plus square root of z naught all over square root of z plus square root of z naught. Okay, then sa taas, syempre, pag multiply, that is simply z minus z naught all over square root of z plus square root of z naught. Okay, so ang obvious, so pag in-arrange ko lang, this is 1 over square root of z plus square root of z naught times z minus z naught. So ang obvious na ito yung ating increment function. So what is IF? So the increment function, which is equal sa p prime p of f of z is equal sa 1 over square root of z plus square root of z naught. Ito yun. Okay, so at z, so at c is equal to z naught, that is equal lang sa 1 over 2 yun, magiging, so this is 2 square root of z naught. Okay, so provided na si z naught is not equal to 0, so this exists. Okay, so provided na si z naught is non-zero, this exists. Okay, so f of z is complex differentiable at z naught which is not equal to 0. So mas mabuti ilagay mo na yun. Okay, and this is done using CTL. Okay, so number 5, use the definition of derivative to prove that the derivative with respect to z of sine z is equal to cosine z. Okay, so ano ba yung definition of derivative na yun? Paalala ko lang. So f prime of z, yung isa, this is equal sa limit as delta z approaches 0 ng f of z plus delta z, okay, minus f of z. Okay, all over delta z. Okay, so yan yung i-apply natin dito. So to prove yung derivative niyan. Okay, so sir, di ba kaya ng Cara Theodory lemma? Parang hindi, kasi hindi ko pa tinry ko, hindi ko makakuha eh. Okay, so dito mas madali ko siya makuha. So ito yung proof. Okay, so the derivative with respect sa z nung sine c ay equal sa limit as delta z approaches 0. Okay, ng f of z, so this is f of z, so since f of z, f natin is sine, so this is sine, okay, so this is sine z plus delta z minus sine z all over delta z. Okay, next is, pansin mo, that is sine z plus delta z, so parang sine a plus b. So apply natin yung sum and difference o yung sum ng sine a plus b, so that is sin cos cosine. So naalala mo, sine cosine plus cosine sine. Okay, so this is equivalent sa limit. Okay, so that is limit delta z approaches 0 ng sin cos cosine, so that is sine z. Okay, so that is sine z cosine of delta z plus cosine sin cos cosine cosine of c tapos sine of delta z, okay, minus sine z all over this is delta z. Okay, next ang gagawin ko, itong sine z na to kukunin ko doon. Kumbaga pagsasamahin ko itong dalawa, parehas kasi may sine z, tapos bibiyakin ko yung fraction. Okay, so meaning parehas silang may over delta z. So ulitin ko lang, ang gagawin na sir is ito yung limit ng delta z approaches 0. So lagyan ko na dito ng malaking bracket. So una is si sine c cosine delta z minus sine c. Okay, kinuha ko yun. All over delta z. Okay, next is, this is plus cosine z tapos sine delta z over delta z. Okay, so next is paghihiwalayin ko yan yung limit. Tama? So magpa-factor ako konti, tapos paghihiwalayin ko yung limit. So meaning dalawang limit kukunin ko. So this is limit as delta z approaches 0 nang pa-factor out ko na yung sine. So in this part, naka-factor si sine c. Okay, multiplied by cosine delta z. So pag binactor yung sine z do, this may matitirang 1. Okay, all over delta z. Okay, then plus limit as delta z approaches 0. Okay, then this is cosine c sine delta z all over delta c. Okay, ngayon pansinin natin nasa loob ng limit. Yung limit, ang kanyang limit is ang maapektuhan si delta z. So meaning ito delta z apektuhan, pero si sine c hindi. Tama. Dito rin si delta z lang yung apektuhan. So meaning si sine c at si cosine c parang constant yung dating nila doon sa loob ng limit na yan. So meaning pwede natin siya i-factor out palabas. Okay, so this is equivalent, gawin ko lang. This is equivalent sa sine c multiplied by limit as delta z approaches 0 ng cosine delta z minus 1 over delta z. Okay, then plus, labas ko dito si cosine c multiplied by limit as delta z approaches 0 ng sine delta z over delta z. Okay, so note that the limit of cosine delta z minus 1 as over delta z as delta z approaches 0 is 0. Kung naalala mo sa advanced calculus. Also, yung limit na itong sine delta z over delta z as delta z approaches 0 is 1. Okay, so meaning, this is equivalent sa sine z multiplied by 0. So, check nyo na lang, plus cosine c, okay, multiplied by 1, which is equal sa cosine c. So, therefore, the derivative of sine c with respect to z is cosine c. And this is done using the definition of derivative. So, ginamit ko yung unang definition. Napansin mo, nakuha ko yung kanyang derivative. Okay, so proceed tayo dito. Let's have lemma. If f is complex differentiable at z0, then f is said to be continuous at z0. So, paano yan ipoprove? Okay, so napakasimple lang yan. To improve, by CTL, there exists p function of f, okay, such that yung f prime of z minus f of z0 is equal to p function of f of z times z minus z0. Okay, so ang gusto niyang kunin si f of z. So meaning si f of z ay equal sa f of z0 plus delta p of z o p function of f z, then z minus z0. So observe na itong part na to is continuous. Bakit? Constant to times function times something a function, binomial function. So linear function times something a function. Then dito, since lahat yan ay continuous, therefore f of z is continuous at z0 kasi andun sa loob si z0 eh. Okay, so that is done by Cara Theodory lemma. Okay, so ganun lang siya kasimple. Okay, next is the chain rule. So hindi ko na ipoprove. So alam nyo na yung chain rule. The derivative with respect sa z ng f of g of z is f prime of g of z times the derivative pa ng loob. So example lang, parang lagay ka na ng example dito. For example, let's kunin natin yung derivative with respect sa z ng sine x squared. Okay, so para simple bang. So this is equivalent sa derivative ng sine is cosine. So this is cosine x squared. Then kukunin mo yung derivative ng x squared which is 2x. And that is equivalent sa 2x cosine x squared. Okay, so ganun lang kasimple si chain rule. So aware na kayo dyan. Okay, so ito lang yung all about sa video na to. So ulit si CTL yung importante dito. So hoping na nag-gets mo CTL. So ang highlight lang talaga is z minus z0. Yun lang hanapin mo, therefore makikita mo yung increment function. Kasi apply mo lang yung mga kailangan i-apply. Okay, so proceed tayo sa next video natin.